Imagine a force hidden beneath one of our planet's most beautiful landscapes. A power so immense, it could reshape continents and alter the course of life on Earth. This isn't science fiction. This is Yellowstone. For years, a question has simmered in the minds of scientists and the public alike. Is this sleeping giant beginning to stir? Is the Yellowstone supervolcano about to blow? It's a thought that captures our imagination and perhaps our deepest fears. The ground there is moving, rising slowly but surely. What is our planet trying to tell us? This isn't just about a single place in Wyoming, it's about the dynamic, living nature of our world. Earth is not a static ball of rock, it has a fiery heart. Yellowstone is more than a name on a map. It has captured the human spirit for centuries, the world's first national park. Here, geysers punch skyward. Old Faithful launches towers of scalding water. The Grand Prismatic Spring glows with colors painted by heat-loving microbes, a landscape teeming with life, bison on the plains, wolves in the forests, a sanctuary of the wild American West. Beneath the beauty lies an incredible secret. Yellowstone is an active supervolcano. The park itself is the collapsed caldera. Geysers, hot springs, bubbling mud pots, and steaming fumaroles, direct evidence of a colossal furnace. The ground here is alive, a living laboratory for Earth's geology. Its ecosystems and headwaters reach far beyond the park. From microbes to moons, Yellowstone connects biology, geology, and astrobiology. Yellowstone's immense power is written in the very rock beneath our feet, a history of eruptions on a scale far beyond anything modern humans have ever witnessed. The vast, serene landscape we see today is a deceptive mask. This entire basin, stretching over 45 miles across, is not a valley carved by rivers, but the collapsed remnant of a colossal volcano, a caldera formed by unimaginable violence. To comprehend what could happen, we must decipher what already did. Geologists become detectives of the deep past, examining volcanic outcrops where each stratum tells a story. They piece together the timeline of the supervolcano's long, turbulent life, moment by violent moment. The most recent of these cataclysmic events, the Lava Creek eruption, occurred roughly 631,000 years ago. It was this blast that created the caldera we see today. This wasn't a gentle lava flow, but a sudden, apocalyptic explosion of unimaginable force, unleashing a superheated pyroclastic flow, a cloud of ash, rock, and gas that raced across the continent. A colossal column of ash was ejected high into the stratosphere, falling back to Earth as a thick, suffocating blanket. This layer of pulverized rock and glass created a sterile gray world, likely triggering a volcanic winter that altered the global climate for years. And this devastating eruption wasn't a singular event. The geologic record reveals a pattern. Yellowstone has produced at least 3 of these massive caldera-forming eruptions, each one reshaping the continent. The very first and largest, the Huckleberry Ridge eruption, exploded 2.1 million years ago. It remains one of the largest volcanic events known to science, spewing out enough material to bury the entire state of Texas several feet deep. Between these two titans, another enormous event, the Mesa Falls eruption, occurred 1.3 million years ago, adding another violent chapter to the region's history and carving its own caldera. The evidence of this fury is found far beyond the park's boundaries. Layers of hardened ash known as tuff have been identified as far away as Nebraska and California, geological fingerprints of the blast. By analyzing the unique chemical signature of these tough layers, scientists reconstruct the size of the ancient explosions and the terrifying reach of their fallout. It's painstaking geochemical detective work, piecing together the story from microscopic crystals. To grasp the scale, consider the 1980 eruption of Mount St. Helens. It was a devastating event that captured the world's attention. Yet Yellowstone's last major blast was at least 1,000 times more powerful. These echoes from the deep past provide crucial context for the energy that still lies dormant. This violent history frames today's geothermal activity, a profound reminder that the same colossal forces that shape this continent still rest, quietly, just beneath the surface. Beneath the serene landscape of Yellowstone, a colossal force is at work. For decades, scientists have detected something both subtle and profound. The ground itself is moving. It's not a sudden tremor, but a slow, rhythmic deformation across the entire caldera. A broad area is steadily inflating, rising upward as if the planet is taking a slow, deep breath. This process, known as uplift, is a direct manifestation of the immense heat engine churning miles below. The uplift isn't uniform, it's concentrated on two features known as resurgent domes, Sour Creek and Mallard Lake. Here, the ground can swell by several centimeters per year, pushed up by past magma intrusions. A few centimeters may sound trivial, but spread across hundreds of square kilometers, it represents an enormous volume change, a clear signal that something is displacing the crust from below. This cycle of breathing isn't new. Surveys since the 1920s reveal a long history of the ground rising and falling. From 2004 to 2010, satellite technology tracked an unusually rapid uplift of up to 25 centimeters, before the rate slowed and even reversed. This is the hallmark of a living, breathing caldera system, constantly adjusting to the pressures from within. The source of this restlessness is a colossal magma reservoir deep underground, but it's not a cavern of liquid rock. Seismic imaging reveals a vast, spongy body of hot, partially molten crystal mush, a slushy of solid crystals suspended in melt, saturated with volcanic gases and superheated water. When new magma from the Earth's mantle is injected into this reservoir, or as gases and fluids accumulate, pressure builds. This flexes the overlying crust upward, causing the ground to rise. Conversely, when pressure eases as magma cools and crystallizes, or when gases escape towards the surface, the ground can relax and sink back down. This is the exhale. Crucially, this movement signals activity, but not necessarily an impending eruption. For that, a much larger volume of eruptible magma would need to accumulate rapidly. This breathing is considered normal behavior for Yellowstone. It's like monitoring a patient's breathing pattern. The regular rhythm is reassuring, but any sudden change demands immediate attention. That's why geologists watch so closely, using a dense network of instruments to track these vital signs with extraordinary precision. How do we know the ground is rising? We can't see it with our eyes. GPS stations fixed to rock detect motions down to millimeters by timing satellite signals. Over time, they map the caldera's subtle breathing 24/7. INSAR compares radar images from space, revealing tiny elevation changes across the park. Seismometers listen, swarms hint at fluids or magma fracturing rock. Together, they provide the best health check a supervolcano has ever had. What if the unthinkable happened? Let's explore with curiosity, not fear. Intense earthquakes as magma surges toward the surface. The ground bulges dramatically. A towering column hurls ash, gas, and pulverized rock tens of miles high. Then the column collapses. Searing pyroclastic flows race for dozens of miles. The park would be buried under hundreds of feet of ash. Fine ash and sulfur dioxide spread on high winds, dimming sunlight, triggering volcanic winter. Heavy, corrosive ash collapses roofs, contaminates water, halts aviation, devastates agriculture. A sobering reminder of Earth's power and why monitoring and research matter. But before we get carried away by doomsday scenarios, it's time for a crucial reality check. The dramatic images of a global catastrophe simply do not reflect our current situation. The scientists at the U.S. Geological Survey and the Yellowstone Volcano Observatory, who monitor the volcano 24/7, are in firm agreement. There is absolutely no evidence that a super eruption is imminent. They aren't just guessing, they're looking for very specific, dramatic precursors. Intense earthquake swarms far beyond the norm, rapid ground deformation measured in feet rather than inches, and significant changes in gas and thermal emissions. None of these signs are present. Yes, the ground does rise and fall, and the earth certainly quakes. Yellowstone experiences between 1,000 and 3,000 earthquakes every year. But this isn't a sign of impending doom. Instead, it's the normal behavior of a living, breathing caldera. The ground swells and subsides with the subtle movements of magma and superheated water miles beneath the surface. These tremors are the volcano's steady heartbeat, not the drumbeat of an approaching disaster. In fact, the odds of a caldera forming eruption in any given year are vanishingly small, about 1 in 730,000 according to the USGS. To put that into perspective, you have a far greater chance of being struck by lightning, or even being hit by a city-ending asteroid. And the popular idea that Yellowstone is overdue for an eruption is a fundamental misunderstanding of geology. Volcanoes don't operate on a human schedule. The vast intervals between past super eruptions are just statistical averages over millions of years, not a ticking clock. The volcano will erupt when the geologic conditions are right, and right now they are not. What is far more likely are smaller, though still significant events. The greatest potential hazard comes from hydrothermal explosions, violent steam-driven blasts that can hurl car-sized rocks over a mile. A lava flow is also possible, but it would likely be a thick, slow-moving rhyolitic flow contained entirely within the caldera boundaries, a major geologic event for the park, but not a global catastrophe. And if the risk of a larger eruption were to escalate, we would know. A dense network of seismometers, high-precision GPS stations, and gas sensors means a major eruption wouldn't be a surprise. It would be preceded by weeks, months, or even years of unambiguous warning signs, providing crucial time to prepare. So, while the sheer power slumbering beneath Yellowstone is endlessly fascinating, there is no scientific reason to lose sleep. The giant is, for all intents and purposes, sleeping soundly. The real story of Yellowstone today isn't about fear, but about unparalleled opportunity. This park is a world-class natural laboratory, a living window into the fundamental forces that shape our planet. By studying the Yellowstone hotspot, we learn how massive plumes of molten rock from the mantle create volcanic chains and shape entire continents. Every GPS measurement and every recorded tremor isn't just a safety check. It's a data point that helps build a four-dimensional model of the vast, complex plumbing system of magma and water that lies beneath our feet. The monitoring techniques honed in this challenging environment have become the global gold standard, now used to safeguard communities living in the shadow of other active volcanoes around the world. And the discoveries extend far beyond geology. In the 1960s, a heat-loving microbe discovered in a Yellowstone hot spring yielded an enzyme that unlocked the polymerase chain reaction, or PCR, a technique that has revolutionized everything from forensic science to medical diagnostics. Today, the exploration continues. Using advanced seismic imaging, scientists are mapping the magma chamber's precise size, shape, and state. Yellowstone is not a threat to be feared, but a scientific treasure offering profound insights into the past, present, and future of our dynamic Earth.